So let me start by showing you first the different types of green technologies. First of all, there's green chemistry. It will get a little bit technical here, but don't worry. We just need to look at the impact of green chemistry and who are working on it, what can it do for us, and understand the negative impacts and the positive impact of it. So green chemistry then moves us to green energy, which is probably the most well-known part of the climate action agenda, which is renewable energy. We'll talk much more about clean energies, what are they, what are the sources, and how can we actually do what we call the transition now to clean energy. And then we'll talk about something very unique, which is green data. How does data help us become more green, more sustainable? Data itself isn't green, but the uses of data, from big data to artificial intelligence to the Internet of Things. Then we think through some of the technologies themselves, the hardware, the production of the hardware, the screens, the material, the motherboards. That in itself has produced a lot of recycled waste or waste that we actually can't recycle. And that's an area we need to think about in terms of design thinking and how can we design for sustainability. And last but not least, we have two areas that are very important. We're going to look at green nanotechnology, and this is a very advanced science. When we talked about the fourth industrial revolution, we talked about the merging between uh, biology, technology, and physics. And the fourth industrial revolution is all about that. So we're going to see how nanotechnology is starting to help us become more green. And of course, we will end all of this by thinking about green buildings and green cities. How can we apply all of this into the built environment? So these are the different areas of green and clean technologies. Each one of them is unique. They're connected and interconnected, but each one of them has its champions, its players. Whatever you're studying, you could be part of these. If you're studying architecture, urban design, social studies, then you're part of the green societies and you're thinking through green societies, built environment, and you're thinking through sustainable cities. If you're studying chemistry, you're looking at green chemistry. If you're studying technology, you're looking at either the production of technology or you're looking at data. If you're studying power, engineering, physics, then you're into renewable energies. If you're studying biology, then you can look at green technology. So you can see no matter what you're studying, from languages to pure science, there is an area and space where you can get involved with green and clean tech. So let us start by looking at one of the more complex areas of green tech, which is green chemistry. The reason I say complex, because if you're not a chemist and you don't understand chemistry, this can become a little bit harder to understand and accept. But think about this. Everything we eat, consume, the paint on our walls, the papers we use to print, this is all based on chemistry and the reaction and certain components coming together. So when we talk about green chemistry, we're talking about those companies who produce these products. And how do they think through the life cycle of these components? It's one thing to make components cheap, affordable, durable, and fit for purpose. But it's another thing to think, what is the impact of these products on our life? First of all, where do these materials come from? Is the whole process of extraction and preparation of these materials sustainable? Is it something is it something depleting our environment? Second of all, how do we use these materials? When we use them, are they producing something that might harm the people with something we smell, something we touch? Third, how do we get rid of them? When we dispose of these things, do they have a lasting impact? Do they have a toxicity effect that we leave behind? So chemistry is all about the products that we use in our lives and the nature of these products all the way through across the whole supply chain, from extracting the material that we use to produce these products, to the process by which we manufacture them, to the actual uses and how we consume them, all the way to how we get rid of them. And across all these four stages, there's different types of chemistry areas that we can think about that make our products more green through green chemistry. So let's take a few examples and think through this. For example, everybody has a house, everybody lives in a certain built environment, and we use a lot of paint. So the paint has many, many complex chemical materials going into it. There's solvents, there's different materials, there's different chemicals. Now, with time and with the improvement of our studies and science, we have realized that some of them are less harmful to others than others to our health. The air we breathe, the smell of the paint, the kind of chemicals that are within the paint. So we're starting to see companies, for example, like Procter and Gamble, but there are many others around the world, working with partners to reduce the harmful effects of some of the substances, some of the solvents that go into some of the material they use. And if you think about solvents, for example, they get into everything, from from rubbers that we use to painting our walls. And if we can think about the starting point of these chemical products, then there is something about thinking what we call through life cycle design. When we are going to use a certain component to produce a certain effect. In the past, we used to say, is this solvent good enough to make this paint visible, good to see, easy to paint? And that was the functional part. But now, when we think through green and clean technology and chemistry, we're thinking, first of all, where is this chemical going to come from? So remember the whole life cycle. Then how will we produce it? Then when we use it and consume it, what are some of the negative externalities that could happen to our bodies, to our eyes, to our hair, to our breathing? And then when we dispose of it, or we try to throw it away, or we try to demolish a certain building, what happens to that paint when it goes and dissolves in the ground? Does it dissolve? Does it get absorbed? Does it cause toxicity? And that is the life cycle thinking that companies like Procter & Gamble are trying to reduce that whole value chain. Let's take another example. The papers we use for printing. It might sound like a very simple thing, but the papers have to be produced in sheets, laminated, and Dow Chemical is working with paper companies like Kohler so that they can produce certain types of paper and certain covering of the sheets that reduces some of the harmful effects when we recycle them later on. And at the same time can still work with thermal printing and laser printing. You can see how these are complex systems. You can reduce the harm from one area and it might cause more ink to be absorbed in the printer. You can reduce the ink that being used in the printer, it will reduce the visibility, which is the functionality of the product. These are not simple linear decisions that we take when it comes to chemistry. Chemistry, like everything else, is a complex system. We have to look at all the variables, and as I said, look across the whole value chain. But these are the kind of exciting advances in green chemistry that are now moving us forward to think about the products we use. Now you have to consider the products we use, everything from juice boxes, to the clothes we use, to the dye in the clothes, to the pens. So these are very everyday activities and everyday products that we use. But now that we're understanding much more, especially now with artificial intelligence, we'll be able to understand much more about the interaction between these chemicals, their effect on the health, how they get absorbed and recycled. There are now new companies starting with very niche focus, specifically on the very obvious areas, like I mentioned, with paint and solvents and so on. Let me now give you another example of some chemical reactions that have been innovated and produce great ideas for our environment. So think through the smog vacuum cleaner. You all have a vacuum cleaner or have seen a vacuum cleaner that you use to clean the dust. Imagine if we have an actual vacuum cleaner that can actually use to clean the air. It sucks the dust and the smog from the air, it compresses it, uses certain chemical reactions and releases clean air. This exists. Not only that, actually the particles collected from that smog can be condensed and produced into products like a potential ring that people wear that is made from smog from the air. A vacuum cleaner for the air that is based on clean and green chemistry. And now that we have discussed green chemistry, let us go to an activity where we think through the products. Map the most 10 usable products that we use every day, whether it's for eating, drinking, going to the gym, driving a car. Think through the chemical composition of these products, and then go back to the supply chain and the value chain and say, where do these chemicals come from? How are they extracted? What is the process to produce them? How do we consume them? What are the potential negative impacts of consuming them? And then all the way to when we get rid of them, what are the potential negative impacts? This mapping of the chemical life cycle of our products tells us where green chemistry can jump in and solve. Again, it could solve by removing harm, it could solve by taking harm that has been done already out, or it could solve for making the extraction process or the recycling process more sustainable. Now we will talk about green energy. Green energy is potentially the most exciting part in terms of the potential for climate action, because it will help us produce clean, sustainable energy. Our world lives on energy. If you think about anything in our life, it requires energy. From charging your mobile phone, to putting the lights on, to driving your car, to flying somewhere. Energy is the blood that flows through the veins of life. Now, energy had a long history. It started with fire. We then produced steam using fire. And then we had fossil fuels, which we could burn. And energy Today, majority of it comes from fossil fuels. And the whole world has reached a point where we said we're going to reach net zero. And in the space of net zero, which you have heard a lot about, we want to produce energy because we need energy to live, but we want the energy to be sustainable, clean, and we want the energy to be able to come from renewable sources. Now, what are the renewable sources? What are sources in our life that can produce energy that are renewable? Renewable sources means sources that don't get depleted. Fossil fuels get depleted because when you burn them, you don't get them back. That's a non-renewable source. What's a renewable source? Think about the sun. The sun is the biggest source of energy in our life. If we can capture that energy, and we'll come some of the technologies, then we have renewable energy because it doesn't deplete. Think about the wind. If you can capture the power of the wind and turn that power of the wind into kinetic energy and capture it, that's renewable. Think about waves and tidal waves and the rain, the movement of the water, where we have dams and we can produce hydro energy. Think about energy we can produce from plants and algae, biofuels. We can also use them because plants, we can regrow them again. And of course, there's geothermal energy. There's a lot of energy in the ground that we can harness, powerful energy that produces volcanoes and other things like that. So these are the sources of green energy. Now, the question isn't about the sources. The question is, can we capture this clean energy from different sources? Can we capture it and store it and use it, and how? This is where technology comes into play. Because we know the energy exists, the trick is, can we capture it, store it, use it, and at an affordable cost? Let's start with solar energy. If we look at solar energy, which is the most abundant energy we have in our lives, it used to be the case 20 years ago where solar energy was very hard to capture because solar panels were expensive. And to produce these solar panels, these are photovoltaic panels, it was very expensive, prohibitive in fact. And there were issues of how do we store it. Even if we can capture it, we have to use it on the spot. There's no way to store it. Now, a few things happened in the last 20 years. First of all, demand and supply, government investments, innovations as well, have started dropping the cost of solar panels to the point where they are unbelievably affordable today. In fact, today cost is not the issue in terms of installing solar panels. We see in countries like Morocco, the United Arab Emirates, China, solar panels are turning into farms. We have whole solar farms. Houses in places like Australia are all installing solar panels. And what happens with solar panels is they capture the energy from the sun and be able to immediately translate it into electricity and other forms of energy we can use in our house. More importantly, it's becoming more and more feasible to store that energy. The advances in batteries for storage and storage equipment for energy are moving forward. And one day when we reach the ability to store vast amounts of energies, because we want to use it on demand, not on availability. That is the whole and biggest challenge of renewable energy. When we reach that point, we will have a whole world living on renewable energy. Now think through some of the innovations that are coming up. In India, for example, Samsung launched a mobile phone that can be charged with solar energy. Now, the trick is how do we improve the battery power so 1 hour of charging can give us 1 hour of talk time. But they exist now. Our houses, the grids are being connected. There are innovations in policies that are allowing us to use solar energy. For example, in places like Australia, houses who have solar panels can use the energy to produce the energy they need in the house. But also there are policies and apps they can use to trade energy. So if I have produced in my house more energy than I need from the solar panels, and you need energy in your house, then we are able to exchange, and I can sell you that excess energy. So you can see that innovations in clean energy are not going to only be technological innovations. We need innovations in policies, we need innovations in behaviors. So this same thing applies to wind energy, and you see the wind turbines everywhere you go, places like Holland, places like the UK, who are relying much more on wind energy to produce part of their requirements. And many of the countries around the world, including countries in the Arab world, have set targets to say by 2030, 2040, 2050, what is the percentage of energy that we require for our society to function that will be produced from renewable sources. And with more advances, and with advances like the example we use with solar power, costs reducing, efficiency getting higher, being able to store, we will find that the future will rely much more on renewable energy. Solar, tidal energy, rain, wind. These are the major sources where we can have, from the elements of nature, continuous production of energy, some form of technological storage and redistribution and use. If we think about another form of energy now, which is also renewable, which is biofuels. Biofuels are exciting because they're plant-based. Things like algae, for example. 12% of the aviation fuel could come from this source. Countries like Mexico have set targets to say 1% are going to be produced from those innovation fuels. And this is with the technology we have today. So imagine this fantastic technology being able to use these biofuels and reduce our reliance on fossil fuels and be able to leverage all of these capabilities of plants and renewable to produce energy where they are today. Now add this to the fourth industrial revolution, where we said Moore's law of every 2 years we double computing power has dropped to 3 months of doubling. And you can see that the future will become very fast. Exponentially, we will be able to increase the uses, we will have more ideas, more potential to produce, and we will be reducing the costs. And when this functionality and cost equation comes to fruition, and when we are cracking the code between how much it costs versus how we can store it, the whole world will be transformed. Hence, you will hear a lot when it comes to energy about transition. And we're talking about fair and equitable transition around the world, because these technologies are expensive. So you can't expect developing nations to be able to install the same wind power energy production that advanced nations have. So this transition has to be fair, equitable, and people have to work together. This is a team sport where the whole world has to work together on policies, on innovations, and on technologies. But there is no doubt that there is enough renewable sources out there, whether it's sun, wind, biofuels, or geothermal energy. There is no doubt that there is enough renewable resources to give us all the energy needs of our Earth. Now, to wrap up this extremely important and critical part of our energy and clean technology discussion, we need to think about two things. One, the technologies themselves. Think through what technologies you see around you. What do you hear of that is developing? Have you heard of new technologies that are ways of producing better energy, storing them? Do you see examples of mega solar farms? Do you hear about wind turbines? Do you hear about more dams being installed? Have you heard much more details of biofuels? Let's think through many examples that we see happening in our part of the world. The investments being put behind them. Who's investing in them? Is it governments? Are they commercial yet? Are private equity and investors putting money behind that? And then when it comes to investments, think through as well the world of finance, because as we said, the biggest challenge to using clean and renewable energy is finance and affordability. How would the world of finance benefit? Why are big banks now giving green loans and sustainable loans? Because there's benefits to both sides. Even the world of crypto will benefit from cleaner energy, and we can move to digital currencies by having cleaner energies. And as you can see, it's all a cycle connected to each other. Now, for the next section, we will talk about green information technology. So the ICT sector has always been a player in the area of climate change, in the sense that in 2018, about 1.4 of the carbon footprint in the world came from that sector. It consumed about 3.6% of global electricity. You might say that's not much. Of course, during COVID times, there were many disruptions, so the statistics have gone haywire between uses increasing in certain areas, reducing in other areas. But since then, we have seen multiple times increases of the uses of electricity because of servers, because of cryptocurrencies, because of AI needs, which is extremely hungry. What happened now is we're saying energy needs AI and AI needs energy, because energy needs AI to reduce its impact, but AI needs a lot of energy. So we've seen a spike in the impact of the Information Technology Center on our carbon footprint and our climate action. Where does this come from? If we think about this whole world of ICT. First of all, the computers we produce, the laptops, the iPads, the printers, these are all very hungry for specific material, whether it's plastics, rare earth metals, and others. So that's the first start. If we want to be more conscious about how we produce these things, we have to start from the design phase, as we mentioned about green chemistry. Second, there is the actual data that these computers run on and the ICT sector runs on. And data farms and data servers are becoming very, very, very energy hungry these days. And the third, of course, is the actual consumption itself. and the actual electricity that it consumes. And now we need everything to be lit up and charged 24/7. So there's multiple areas where the ICT sector impacts our climate. A lot of it has to do with our own consumption. A lot of it has to do with what we do as companies. Some of it has to do with how we consume these equipment and how much we consume them. But there is no scenario, in our mind at least, in the future where the world will be less technical. If anything, in the next 10, 20, 30 years, our world will be more technical, more digital. We will consume more data. We will need more smart glasses. We will need more smart watches. We will produce more computers. We will deal with more artificial intelligence. So if anything, this trend is going to increase, and we need more electricity, we need more production, we need more motherboards, microchips. Even if we move to quantum computing and we stop using the traditional microchips, we still will need a lot of these resources, and hence we should think about how to green our ICT sector. So let us start now with thinking through how these things work together. Because to make this sector green, it's not about production. It's not as simple as renewable energy, or as simple in the sense that it's contained as green chemistry. Let's take an example of a university. There's a university in the US who decided to go green on their technology use. First of all, we start with green procurement. When you buy new equipment from the ICT sector, are you buying it from suppliers who are responsible? Companies like Dell have claimed that they are using only responsible tools, materials in their production, in their sourcing, and in their recycling. Has the government set, or the university set, or somebody else has set some policies around reuse? We've seen now this whole idea of reuse and refurbishment in this sector booming. Countries like France now give people back some money to actually take their old equipment and refurbish it instead of buying new one. These are rebates. These are policy decisions, but still make the sector more green. Have we, the university as well, talked about limiting certain services? Sometimes we consume without thinking through printing certain papers once and twice and three times. How do we limit the printing services? Every single thing we do in this sector will consume certain material and will consume energy. So in the ICT sector, one of the biggest areas is reducing consumption and containing it. However, this is not the only area we need to talk about the ICT sector. We have to also consider the reuse, and I think the biggest area here is this whole reuse and recycle, which you have heard a lot about in the circular economy module, and this is a core part of the circular economy modules. Because today, one of the biggest areas of waste that we cannot get a handle on and recycle very easily is electronic waste. And we have seen now programs across the board, and this requires policy changes, this requires companies to change their production processes, and requires people to change how they consume and they live sustainably. So if we want to move towards more green IT systems, what is needed? First of all, and as I mentioned earlier, and as we mentioned in this course, there's a lot of focus on the role of the private sector. The private sector is the one who decides a lot of these things by way of investing in innovation, but by way of also committing to doing no harm, committing to be able to sustainably source some of the material, committing to improving their production lines, even if it increases the cost marginally, committing to a lot of the areas on how they ship their products. In fact, the private sector is probably where the green ICT sector has to be born and nurtured. Now, this will be helped a lot by regulations from the government, reducing, reusing, and reducing the use. There's a lot of green procurement as well taking place. If we think through the next 20 years, the one thing that is for sure is that this sector is going to grow. Our consumption is going to grow. We will use more equipment, but we can also grow our repository of data. We'll talk about green data and how we use that to actually think through better decision making. But the sector itself is a consumable sector, and it's becoming very fast moving. Even discussions are taking place now about how fast some of these companies that are working out there are changing the models and introducing new models. Because every time they introduce a new model, they cause a whole world of waste from the old models. So these are all behavioral nudge aspects that have to do with public policy and have to do with production lines. So production engineers, sourcing engineers, and even procurement officers will play a role in this space. So if we want to think through this now, how can we imagine a world that has a much more sustainable ICT sector? Where do these computers come from? The laptops, the phones, this whole ICT sector, the printers we use, how can it be more consumable? Is it behaviors? Is it policies or is it production lines? Think through examples from our lives where we see these things actually taking place, and where are the high wastage areas? Where are the areas that we can reduce? And I think that this gives us a clear indication that green technology and clean tech isn't only about technology, isn't about innovation, isn't about hardware. It's about consumption, it's about how we think through it, it's about design. The most sustainable products in the ICT sector will start from a green design. And green design is all about being able to design the right things. So the idea of green technology is much bigger than technology itself. It has to do everything from green design and the conceptual thinking about the design and what goes into a product and how we produce it, all the way to how we procure it and how we incentivize that, all the way to consuming it and how much we consume and how much we print and how much electricity and how much we charge, and do we switch off or we don't switch off when we're not using it, all the way to how we dispose of it. So you can see that this is a socio-economic agenda, not just a technological agenda, especially when it comes to the green ICT sector. Now we're going to talk about green nanotechnology. So this is about to get a little bit specific and a little bit complex, but very exciting. When we talked about the fourth industrial revolution, we talked about this revolution being the merging between technology and biology. Now, when we say something is nano, that means it's smaller than 100 nanometers. Now, this is infinitesimally small. You cannot see it, you cannot feel it. These are things that are unbelievably small that the naked eye cannot see them. We have to barely see them with big magnifiers. When we talk about the world of nano, we're looking at the level of molecules. Now, the world of nano has been able to improve a lot of things in our biology, in medical research. When technology merged with nanobiology, we started seeing today inventions, things like robots, small nanorobots that can go and swim inside the human body and take pictures of certain cells. That is the level we're talking about. So, what does this have to do with sustainability? These are exciting developments in biology and technology. They have a lot to do with sustainability because the world of nanotechnology now allows us to improve things that we couldn't manage in the past, in production processes, in filtration, in improvement of the quality of air, in improvement of the quality of water. At the expense of getting too technical, we're going to take just two examples to think through how nanotechnologies have helped us improve technology, has helped us improve sustainability, and moved us toward a more greener future. We'll take the first example from water. In fact, we'll take two examples from water. One is water filtration, and the other is air to water. So now when we think about water, purifying the water has been one of the biggest challenges in our lives. There's a lot of water around us, but it needs to be purified. You need to take many elements out of it, and these are very micro elements. These are nano elements. Now, the more design, the more thinking, the more technologies we can produce in terms of water filtration, the better, cleaner water we can produce. So we're seeing a lot of exciting advances when it comes to water purification in nanotechnology. What does it mean? It means we can produce better, cleaner, more sustainable water on demand. We're requiring less chemicals to filter and clean the water, requiring less processes, requiring less storage of clean water and production and transportation. So being able to use nanotechnology for better water purification is going to be a huge development to solve one of the biggest challenges in our world. In fact, if you look at the Middle East and Africa, the biggest number one challenge of sustainability is water, is the lack of water for drinking, for farming, and it's going to get more challenging in the future, especially with the climate change and the more drier weather that we're expecting in many places. So water purification and water cleaning becomes unbelievably important, and nanotechnology, especially in the area of filtration and being able to go down to that level, is going to be a breakthrough technology, and we already see some exciting examples. Let me give you one example. We have now technologies around the world that are able to take air, condensation, humidity in the air, and turn it into drinkable water. It's called air-to-water technology. Now, this is thanks to a lot of nanotechnology, which we're not going to go into in detail, but suffice it to say, we have technology now that's able to capture humidity from the air, condense it, contain it, and then be able to apply a certain set of filters to remove certain elements and keep other elements, and then pass it through another layer of condensation, and then apply ozone and ultraviolet light to it and purify it, and produce drinkable water. Think about this, what used to be seem like magic, where we take something from the air and turn it into drinkable water. This is the power of nanotechnology. That's why we say it's green. It's not going to be green in the sense that it will do things like renewable energy and produce other sorts of energies. It will be green in the sense that it will help us produce resources that we need, like water, like purifying the air. There's a lot of applications for air purification from nanotechnology, taking some of the things out of the air, the harmful substances out of the air. And hence, if we see now, think about through the technologies that we call green and clean tech, you can see the value chain from green chemistry to the renewable energies that produce more, to now the nanotechnology that help us purify our resources and be able to recycle. Imagine the recyclable water that we can benefit from in terms of farming and being able to do many things with filtration of the air. So you can see that once these technologies start working together in one system, our whole world can become much more sustainable. We can use less resources. So the challenge now, which is going to be a tough one, is to think through what other areas of nanotechnology can help us build a more sustainable future. The areas we need to think about effectively are our water, our air, the resources we consume. These are the areas in farming. Nanotechnology now can work at the molecular level. We can start changing certain areas in our plants, in how we plant, in how we use pesticides. And you can see how nanotechnology and green chemistry are not very far apart. Think through some of these areas. Who are the top companies that you can think of that come to mind when it comes to this area? And what are the potential breakthrough improvements that could take place in the next decades? At this point in the module, let us stop and take a case study before we move into the last two pieces of the green technology. And let us think about one company. If they decided to go green, let's take the example of Siemens, but you could take any other company. Look around you, look at the companies around you. How can they become more sustainable? You will see now the complexity in trying to bring together renewable energy with green chemistry, with green design, reuse, recycling, nanotechnology, and so on. For a company like Siemens, first of all, they have to figure out the design of their products. That's where you start. You start from the core. Whether you're producing washing machines, dishwashers, electronic equipment, these products have a whole value chain from the material they use to actually the material that they recycle at the very end, when the end of life cycle. And the production process itself, how much electricity it consumes. And then there's the issue of management. So it's not only good to say we're going to use sustainable products. Where do you buy these products? Who do you buy them from? Do you buy them from suppliers themselves follow sustainable practices? So there's this whole issue of management, procurement, sourcing, shipping. Are you buying them from faraway places? And you require much more shipping in the ships, which will require to emit much more energy. So you can see now that we're just talking about products. Now, we finished with the products. They're thinking about how do people consume their products? Are they educating their customers? Are they working closely with their customers? Other areas to think about is how are we building our supplier base? How are we helping them? And then our own buildings. Are they green? Are they made of green building design, which we will talk about? Are the buildings consuming too much energy? So when you think about the company itself, there are multiple aspects that you should draw in a complex system. Let's call it the company sustainable system. Start drawing them in your mind and put them on paper. The products, which has a lot of things to do with the chemistry, design, nanotechnology, whatever the product is, and the services. Then around the products, you have the management techniques. So how do you procure? How do you buy? How do you incentivize your suppliers? How do you educate your consumers? And then around that is your production processes, how much you consume yourself in terms of shipping, storing, moving goods, putting people in offices. And then outside that is your commitments that you're making. Because if you don't have targets for every single one of these levels in terms of using technology at every single level, you will not be able to move forward. So you can see these concentric circles require a lot from a certain company, let alone a country, to deploy all these green technologies and clean technologies. And hence, this requires a very detailed plan for everything any company wants to do or any country wants to do to be able to deploy all these technologies. Now we will talk about food, because we talked about green food technologies. Now the thinking about food has to go back to show you how complex the system is. If you think about food, whether it's meat, vegetables, anything we consume, Starts from the farm, starts from the source, all the way to how we consume it, all the way to our kitchens and the equipment we use and the restaurants. And the whole value chain requires to be more green. Let's start from the source. There are advances today in farming that are using less water, hydroponic, vertical farming. There are advances in farming and farm management techniques that are using solar energy to be able to help with irrigation. There are advances that are using satellite data to be able to spot problems, reduce the chemical usage. This links to chemistry. This is where water comes in here, and nanotechnology helps us purify the water. So you can see that the upstream of farming and the upstream of production of food has a lot of these green technologies already built in. If we move down to the production process, how fast and how far, how do we consume, how much chillers do we need? There are advances in, like we mentioned, the example of Siemens and producing chillers and fridges that require less energy. But one of the exciting areas about food now is the area of recycling and reuse. And this is more behavioral. This is not about technology. This is where we're using technologies like the Internet of Things, like applications, to be able to identify how to redeploy food waste. So there are applications out there now that are helping people identify when they have produced certain amounts of food, how to reuse this amount of food, how to give it to people who need it. So there's something about using data technology, Internet of Things, apps, the connectivity, to be able to recycle our food. Restaurants who produce excessive amount of food at the end of the day, it used to be thrown away. Now they can identify people that can use this. They can identify places that it can be recycled. So when we think about food technology, don't think only about the upstream, which is all the other stuff we talked about in terms of chemistry, in terms of nanotechnology, and in terms of renewable energy. Think of the downstream and the consumption of food, the storage of food, where we put it in supermarkets, where we put it in our homes, how much we buy in terms of food and storage. Are we buying as much as we need, or we're buying a lot to store them? And how we use technology and data to monitor consumption. Technology and data will help us reduce our consumption, reduce the value of consumption and the value of waste in our consumption. And this is where we get very exciting applications these days from things like the Internet of Things, and we see them more and more in our smart buildings and our smart cities and smart storage solutions, which we will talk about more. Now let's take some examples and think through this, because we want to start thinking about smart cities now. Let's start connecting the dots and think where technology can seamlessly integrate into our lives. So the best way to think through this is to think about a typical day when somebody wakes up, and map a typical day from waking up until sleeping, and think in each one of these areas where we are causing harm or doing something to the environment, whether it's consumption, driving, and which of the green technologies we talked about can help improve that aspect of life. Think through this and discuss it and look at the whole supply chain. And always remember that the upstream is equally as important as the downstream. Technology isn't about only technical processes, it's about management of these processes and the consumption of these processes. And we'll talk about a whole cycle and a whole life chain here of using and reusing.